So Kirchhoff's rules tell you that the junction, the sum of the currents in the junction should be equal to 0, and then the loop equation gives you the sum of the voltages 0. In this circuit, we have one resistance here, and then two serial parallel connected resistances there, okay? And then we have this combination. In this thing, first thing that we have done is to name the current. So we said that this is, okay, I1 here. This I1, and I1 is coming this way, and then these two currents are I2 and I3. This is what we picked, and then they will add up and get this. So basically, if I1 is leaving this power supply, the same current is coming back to the same supply. So by using this branch, okay, we can write this I1 equals I2 plus I3. One incoming, two outgoing. And for this branch, exactly we have the same case. So this is the first branch equation we have written. Now the first loop equation, this is loop number 1, okay, this one. Minus V, we enter from the minus side, and then plus V1, and then plus V2, as you see, is equal to 0. So number 2 loop equation. Now we start from here, say arbitrary point there, and then we go now backward, as you see. The current is in opposite direction to our rotation. So minus V2 here, minus V2, and then if I go down, plus V3, okay, is equal to 0. So this shows you that V2 should be equal to V3. This is obvious because these two resistances are connected in series to the same point. So basically the voltages will be exactly the same. Okay, the voltages will be exactly the same. Okay, so this is how we can analyze this problem. Okay, so let's give a numerical example here. In this numerical example, let's say that we have now this. Actually, today we will do some experiment also. I will show you. Let's put this here, and then let's write these values. Okay, so now the circuit is such that this is 4 volts plus and minus. Okay, 3.3 ohms here, and then 222 ohms connected in parallel. Okay, this is 22 and this is 22. Okay, so 4 volts. So this is what we would like to get. So in order to get this current, the first thing we have to do is to get equivalent resistance across this 4 volts. Okay, this is 4 volts plus and minus. So we will get only single resistance, which is R equivalent. If we can get this, then we can really get this I, which is I1. I name this as I1. So I1 can readily be found. So now, what is that? 22 parallel to 22, which gives you 11 ohms, okay? And then it is connected in series to 3.3, so 22 parallel 22 plus 3.3. This is how I do this, okay? So this shows you what to do. So 22 connected in parallel to 22, which is 11, okay? The half of it, 22 times 22 divided by 22 plus 22 gives 11 plus 3.3, and it gives you 14.3 ohms, okay, if you look from this side. Okay, so if it is so, then I1 is very simple. I1 is just 4 over 14.3 because 4 volts and 14.3 is the resistance, and I1 simply becomes 0.28 amperes, okay, 0.28 amperes. So the current that is leaving this 0.28 amperes is found. If it is so, then the potential is easily found because to get the potential through this resistance, all you have to do is multiply these two V equals IR, the current and the resistance values are multiplied, and it gives you 0.92 volts plus and minus. So this was plus and minus 0.92 volts, okay? So now it's easy to get these voltages because, okay, when you subtract 0.92 from 4 volts, it gives you 3.08 volts. It must be 3.08 volts there, plus and minus. Also, the currents are easy to be found because if this is 0.28 amperes, the half of that will pass here, the half of that will pass there. So it's 0.14 amperes there and 0.14 amperes there. So now the product of 22 by 0.14 is just 308. It's very simple. So these are the results that we obtain. Now we have solved the potentials and also the currents in this circuit. So it means that the circuit is solved. So this will be also plus and minus 3.08 volts. Okay. Now we will do some experiments today. Okay, we will do an experiment. So the experiment is here. I will show you the power supply here now. As you see, this is the power supply, which is already set to 4 volts here. It's not easily seen, but it's 4 volts, okay? So now I used the right channel, and also it gives you the current. So this is the power supply, which has these 2 wires, okay? These 2 wires, and I will connect them. So now, let me put this camera back into its original position. Now let me just make this nearer to you. As you see, we have now plus and minus will be there, okay? Plus will be applied here, and minus applied here. And then the first resistance, this one is 3.3 ohms, and these 2 are 22 ohms each. So if I put this sideways a little bit, you see there are legs of this, okay? And this is ceramic resistance, and they are 5 watts. It means that they can really withstand the high currents. So now I'm putting this down and then make a little bit measurements, okay? Okay. Now I will do some measurements. But before I have to apply the power, okay? So I'm just putting this in. So plus side is applied, and minus side is also applied. Okay. There we go. Now, some kind of current is passing. Now, remember that it was 0.28 amperes that we found. Now let's check. Okay. Let's check. It is really 0.28 amperes. So it's really okay. So the first measurement is okay because the power supply is directly given to me the result. Now I will do the measurement with this multimeter. Okay, this multimeter. With this multimeter, you can measure voltages, you can measure the resistances, capacitances, temperature, and also currents there, as you see. Now, since we are measuring voltages, okay, I just turn this to V, okay, and now these things are connected here. Okay, red and common black. So I will make some measurements, okay? So now I'm putting this here. I will show you the potentials. So now this potential that you can measure, okay? As you see now, I'm touching these points, okay? Because this is plus and minus, okay, I have to do this, plus and minus now. If I touch here, you see 3.02 something. So it's like we found 3.08, but this shows 3.2 02 something. So it's really close. It's probably the difference is probably because of the tolerances of the resistances or the calibration of this multimeter. But anyway, it's okay. Let's see that if this is 0.92 volts. Okay, this is one of the. Okay, one of the tip is connected here, the other is right there, and as you see, it's the connection is not good, so you have to be careful. Now, let's check. Okay, here it is. So 0.92 volts. So exactly 0.92 volts. So it works. Basically, we did the experiment, and it seems that everything is working. You will also do the same experiments. So to make the measurement of voltage, we connected this directly to the legs of these resistances. So we disconnect now the power supply, and we turn this off, and then we take this outside, okay, from the breadboard. This is called breadboard. Now I will measure the resistance of this. It says 22 ohms there, okay? Now, I will do ohms measurement. So here it is. So I turned this thing into ohms, and now I'm getting these tips and holding with my hand. The other you shouldn't touch because your body will be connected then. So when I touch there, it gives you 22.6 or 5 ohms. As you see, the resistance increased a little bit because now when I touch this resistance, it's a little bit warm because the current was passing through, and because of this, its value increases just a little bit. Okay, so this is a tolerance also. So there are two things that the resistance will change. One is the temperature increase, the other is the tolerance. So plus and minus some kind of error we have. Okay, good. Now we've completed this first experiment, and we continue now with the next example.